Hello everybody in the statistics class at Mary Baldwin College. I posted a little agenda on this mini little lecture that'll prepare you for our face-to-face class next week, and going to kind of follow some book information for this. So if you want to turn to page 235, version 9, we're going to look at the infamous blueberry hypothesis. Are you familiar with this? It's example 8.1. The idea that blueberries might actually help neuropsychological functioning is the question we're going to kind of look at here. So if you read example 8.1, the idea is blueberries are considered antioxidants. So the question that is phrased in example 8.1, can it actually help people out? And so what we're going to do is we're going to do something called hypothesis testing, and I'm going to take you on the pathway to dealing with this. And the first thing that I'm going to introduce, if you go down to letter B there, kind of the old formula that we were using before the test, and then the new formula that we're going to have this time. So the old formula, if you remember, if you wanted to know how somebody did, the somebody would represent X, the individual, mu would mean the population mean, and then sigma, the standard deviation, is kind of a measure of dispersion. You remember that particular formula was used if you want to know, I got a score of 115 on an IQ, somebody else got 100, how much better did I do? Well, for this new situation, as you read in example 8.1, the idea is now, if you look at it, it's got a sample here, where they gave a sample of 25 adults, some of these blueberries, and they want to see if it actually worked. So if you look at the new formula, you'll notice there are two kind of major differences in the new formula. Can you figure out what they are? Well, one difference is in the numerator. The numerator is many times called the treatment effect. The numerator, now it doesn't say x minus mu. What does it say? X bar minus mu. So the idea is it's a mean. It's a sample mean. Do you know why we're dealing with the sample mean? Well, the idea is now we're working with 25 people in this particular situation, so we're going to collect the mean of what these people do when they eat the blueberries. And the idea is hopefully it will help them out with the blueberries. The other difference you may notice is the denominator. Now, instead of having sigma, we have sigma divided by the square root of n. And the idea is with this one, now we have to consider what is our sample size. So now we're dealing with a sample. So the numerator reflects that, and so does the denominator. Now, the other thing that I would ask you to notice here is kind of some other small differences in this new z-score formula. The numerator is given kind of a name. The numerator is often called the treatment effect. It's often called the treatment effect. And to illustrate this, let's just look at this problem in a little more detail. Notice, what does it say? There's a new score. The average for adults is what? 80 in this particular situation. And now the idea is if the mean score, well, did they actually give a new mean score for us somewhere on this? I hope they potentially did, but maybe they didn't, so I'll get back to that in a little bit. But anyway, the new formula reflects the fact that we're working with a sample here. So hopefully you've got that down, and that makes some sense for you. I'll stop the first recording here.